differential privacy. Differential privacy. This is the era of differential privacy, because till differential privacy there are various loopholes in anonymization technique. What is the main role of differential privacy? And I will provide you a basic idea. What we are going to achieve with the help of differential privacy. Differential privacy guarantees that anyone can participate for statistical analysis without worry about leaking of their individual data. This is the main theme on which it is working, and it is ensuring the individual privacy of a record among data set. And you can also better understand, it also claims that nothing could be learned about an individual while we are learning useful information about a population. There is a data set of a population, then it may contain a record of a particular individual, may not contain, but differential privacy guarantees that we can use that particular group of records for analysis for a common purpose, but we can't disclose the information about an individual person. This guarantee is provided by the differential privacy. This concept was proposed by Cynthia Dwork in 2006, and many of the companies like Google and Apple, Microsoft are now adopting in their data collection, data analysis, differential privacy, and ensuring that the information privacy leak of any individual should not be compromised. And what Cynthia had proposed, she proposed use of Laplace distribution. We have already used a probability distribution. So Laplace and Gaussian, these are the also probability distributions. Cynthia had adopted Laplace distribution for creating noise, for making data anonymous. Cynthia had proposed the Laplace distribution involvement for creating the noise. Noise means we are making anonymity using some random sampling. We are using a Laplace distribution. We can use other randomized functions for creating some noise. There are various terms. First term is epsilon, and it is the parameter for controlling. It can be used by a data analyst to maintain the trade-off between privacy and accuracy. You have already heard about in algorithm data structures like trade-off of time and space. When we are increasing the time, then space will compromise, and when we are increasing space, then time. The same trade-off is also happening with privacy and accuracy. The epsilon is the parameter that is used in differential privacy, and it can be controlled by the data analyst. Data analyst will provide different values of epsilon for maintaining the privacy and accuracy of the data set. Another parameter is delta. There are two other more parameter you have to understand. D1 is the data set 1, and D2 is the also data set. And what is the relation between these two data set? These data set differ by only one record. Only one element means only one record. Differential privacy, you can say the full mathematical concept of achieving data privacy. Apple is using LDP, local differential privacy. There is another concept, global differential privacy also. This is the overall concept. Suppose we have a data set, and this data set is used for a ML model, and it is predicting a probability of a disease is 0.63. Now the again data set is D2, and D2 is including Sushant and the record D1 plus Sushant. Sushant is the record that was not available in D1, now it is available in D2. And again I am applying this data set on a model, and it is predicting the disease probability 0.68%. Now you can see the slight increment in the result. You can say you can't be sure Sushant may be that disease. So this type of guarantee is done by differential privacy. Another concept that is leading to a privacy leak. Again a data set D1 and applying on a ML model providing probability 0.63, but this time when I am including Sushant in the data set, and now it is predicting 0.83, then there is a chances that anyone can assure that Sushant is suffering from that disease. This is a privacy leak, and the target of differential privacy is minimize this gap. If this gap is minimized, then we can achieve the privacy of an individual person. There are some mathematical calculation on privacy loss. You can see in the first example how much privacy is lost. How we can calculate? We can take the log of 0.68 upon privacy loss calculation 0.6. In first case, this is the when we are using differential privacy, this is the privacy loss, and when we are using second approach without DP, and then we are getting, this is the, we compare the both results. There are approximate 4 times we are getting the privacy loss, because this is the 0.27 and now the first one is the 0.07. So this is the goal of differential privacy, to minimize the privacy loss. And both concept, P means probability and M is the mechanism. Mechanism means either we are using Laplace, we are using Gaussian and other mechanism on the data set. And this is the epsilon, and it is providing upper bound, similar to algorithm analysis. Upper bound, big O, you have already heard big O notation. This is the upper bound epsilon, and when we simplifying this result, then this what we are getting something like this, e to the power epsilon, because log base e, when we are removing log base e and putting on this side, then e to the power epsilon, and probability and M is the mechanism. This is the epsilon role in this mathematical formula of differential privacy, and it is also known as epsilon, and the value of epsilon is controlled by the data analyst. They will decide which type of values we want to put, so that how much we can ensure privacy and how we can get accuracy. What is the conclusion from Cynthia? The smaller the budget, and this is the budget, epsilon is the budget. If you will increase the value of epsilon, then larger the budget, less private, and smaller the budget, more private. This is the conclusion from Cynthia. You can go into detail for the mechanism like Laplace distribution. What is the support from Python? Python support for differential privacy, you can note down. This is there are number of libraries from Pythons for achieving differential privacy. IBM is also working for it. The library name is diff priv lib. OpenDP, Smart Noise. Open-minded is working with Google, and they have produced 2 libraries, PyDP and diffpriv, for differential privacy achievement. And then P-Inc and TensorFlow. Many of you heard about TensorFlow. The TensorFlow modules are also implemented for the privacy, for achieving differential privacy. One of the popular is PyTorch. PyTorch is also for differential privacy achievement. Now the web mechanism M. What is M in before D1? The M is the example of M. We can use Laplace, we can use Gaussian mechanism, exponential mechanism. One of the popular mechanisms initially was proposed, randomized response mechanism, that is the flip coins mechanism. We can flip coins and then provide the answers. Google also shifted to differential privacy modules. They have enriched their security with the help of differential privacy libraries for securing the data sets and for the securing the information of an individual users. These are the many things that's going on in today's scenario.